Welcome to deploy a FastAPI microservice for our Try Django project. Now, the goal of this microservice is to have a way to extract text from an image. Now, we're going to be using a third-party library called Tesseract to make that happen. But the general idea is it's actually a machine learning algorithm that's going to extract data from an image, the data that we want. Now, the reason it's a microservice is because it's a service that our Try Django project needs, that is Try Django 3.2. But it is a very valuable thing to learn how to deploy anything into production, but especially machine learning algorithms. And that's what we're going to be doing in this one. So we're going to be using DigitalOcean's App Platform to make this happen because, well, it sort of simplifies the process because we can use a Docker container in a Docker image. Don't worry if you don't know about Docker. Don't worry if that sort of scares you. It's just really one document. I'm going to show you exactly how to do it. Everything is going to be done step by step. My name is Justin Mitchell, so let's go ahead and get started. All right, so let's go ahead and talk about the requirements for this project. First and foremost, the actual technical requirements will always be listed at the GitHub repo, including if we have to update any of the code in the future, if you guys do as well. Now, this GitHub will be linked in the description, so check that out for all of the code. You could probably learn how to do the entire series directly from the code if you've done a number of Python things. Next, we're going to go ahead and use VS Code, so Visual Studio Code. It's free, open source. You can absolutely use this for all of your projects. I highly recommend it for this one. We will be using several extensions in here that I think make actually deploying our project really, really easy. Next thing, we're going to be wanting to have some experience with Python. So if you haven't installed Python on your machine or you have no experience with Python, definitely take a look at our 30 Days of Python series and up to maybe day 15, day 16. That also shows you how to build a web app too. So perhaps you don't even have to go that far. But the general idea is you want some foundation in Python. Like, do you know how classes work? Do you know how functions work? Do you know what decorators are? Even if you don't know how they work, do you know what they are? Those sorts of things are kind of the skill requirements here. And then also make sure that you have Git installed on your machine. And then lastly, I worked with DigitalOcean on this one to bring it to you guys. So they definitely did sponsor this series. So be sure to sign up with a new account on DigitalOcean. So do.co/CFE-YouTube. Check it out there and then go ahead and get into your console. This is where we're going to be working when we go into production. So now let's go ahead and actually set up our environment. Now let's go ahead and set up our environment. Now I'm already in VS Code to do the setting up for this project. The main thing here is setting up VS Code and also our virtual environment. So first things first, I'm going to go ahead and open up this Explorer here, go to open folder, go into our dev folder. I'm going to create a new one and I'm going to call this MS FastAPI and Django, or really microservice with FastAPI and Django. So let's go ahead and put it in there. And then I'm going to go ahead and initialize a virtual environment. So let's go ahead and open up our terminal with Control tilde. And you can also see up here the shortcut for it, depending on what system you're on, which really shouldn't matter for you. So I'm going to use Python 3.8 here, and we'll use the module venv and period. Now, the reason that I'm using 3.8 versus any other version of Python is because I know everything I'm going to be doing here works with Python 3.8. And if it doesn't, it's really easy to go backwards to 3.6. So let's go ahead and activate our virtual environment, source bin/activate. Great, that's what we want. Next thing, we're going to go ahead and actually save this file, save workspace as, and again, we'll do MS FastAPI Django. Okay, cool. So next thing, I'm going to go ahead and make sure Git is installed. And again, we have Git installed here. This is the version I'm working on. Of course, you can use a later version. Git, the actual tool itself, doesn't change a whole lot. So you should be fine with a later version or even an older version. So I'm going to go ahead and initialize my Git repo here. And so this is, of course, going to be for production. Now, one of the things that VS Code has built in is source control. It actually has Git built in, which is nice because then we don't actually have to know that much about Git to even use it. But as we see, we have all of these changes. These, of course, are things that I do not want to have in production. So what I'm going to do is I'm going to do a quick search on Google for a git ignore file and Python. I literally do this all the time, almost for every project I have. This is the git ignore. Now you can also go to the GitHub git ignore. It's probably just as easy to go here and find the Python one. I'll copy that. And we're going to add in a .git ignore file here. And we'll paste this in, save it. And no surprise, what will happen with this repo, especially if you hit a refresh here, it's going to start to ignore a bunch of things. It did not ignore everything, but it ignored a lot of things. So anything that's green, it's going to not ignore. Anything that's gray, it will ignore, which I'm going to add in bin and include. I do not want those in here. In fact, I really only want pretty much one file. We could have the other files in here. I'll leave those in just for future reference. But this is sort of the baseline thing that I want. And then for Mac users, we're going to do .ds store on here as well. That is certainly not something we need. That's only for Mac users. If you're on Windows or Linux, you should be fine. You can also include it too. It's not going to do anything if you include it. So now that we've got that, we're going to go ahead and do our initial commit with git add -- all, git commit, and initial commit. No big surprise here at all. Hopefully you've done some of these things. Now that puts us together with our virtual environment and our Git repo, but our environment is not complete yet. What we're also going to get is an extension for Docker. Now, even if you don't have Docker installed on your machine, install this in here. This will actually help us with a number of things. It might require Docker to be installed. So if it does require Docker to be installed, you can ignore it, but we actually will create a Docker file later, and that's what this is going to allow us to do. It's going to help us manage that Docker file later so we can manage the environment we're going to go into. And that's pretty much it. That's pretty much setting up everything we need with the environment. There is one other aspect that you probably want to do, and that is logging in to your own GitHub account. And then you can either fork the repository that I have, or you're going to go ahead and create your own, right? So if you were to log in to your own GitHub account, and let's see here, you would come in and create a new repository, and then you're going to call it whatever you want. So in this case, you could call it MS FastAPI Django, just like we did. And then you can come through and create this repository. Now I'm going to end up deleting this one because this is not the repository I will use. So everybody will have access to it, which you'll see in a future video. But the general idea is you want to make sure you have this, and then we just need to add our remote and then push it, right? So I'll go ahead and just show you what the commands are without doing it. If you've never done this before, there's that first command, and then it would be git push origin main. So there's a chance that main is not where you're on, which you'll see right here. If it says master, then just change it to git push origin master. There are ways to change the branch. I'm just not going to cover that right now. So that's our environment. We should have a Git repo set up. We should have a virtual environment set up, the git ignore set up. We should have all of our VS Code stuff that we really need at this time set up. And then we should also have an actual GitHub repository so we can push our code into production, which is something we're going to do very, very early in this series. Now we're going to go ahead and implement the foundation of our Python microservice, building a really simple FastAPI application with a Jinja template. Now, the reason we're going to build this microservice is to offload any sort of demand or load on our primary application, whatever that is. It doesn't have to be Django. Ours is geared towards Django for a much bigger project, but this one is just about focusing on one thing, and that is doing OCR. We'll get into the technical aspects of that later, but the general idea here is I just want one single service that's going to do OCR for all of my potential services. So that doesn't mean just one single project. That could be thousands upon thousands of projects, which is why we're going to be implementing this as a microservice. You could think of it as a much bigger service as well. It doesn't have to be a microservice per se, but in our case, we're doing it specifically for one project that might grow into multiple projects that end up using this. So without further ado, let's go ahead and get this started. First and foremost, I want to make a folder in here called app. And inside of here, we'll go ahead and put an init file. So 2 underscores init 2 underscores .py. And then we'll go ahead and add one more file in here. And we're going to call this main.py. This is a very common way to structure a FastAPI app. It's not always in the module app. Sometimes you'll see server, sometimes you'll see source, sometimes you'll see main.py and the root of the project. That part doesn't really matter. You just have to remember where your main.py is. And so before I even configure main.py, let's go ahead and do one more thing, which is creating requirements.txt. Now notice this is the root of my folder. Now I could put it in the app or I could put it in this root folder. Again, you need to recognize where you're putting it for the future. Now what I'm going to be doing is using FastAPI. I'm going to be using gUnicorn and UVicorn. So gUnicorn and UVicorn can work together, and we will be implementing that when we go into production, not when we're going locally. And I already have my virtual environment activated. So if you don't have it activated, you're going to use source bin/activate if you're on Mac or Linux, or of course, if you're on Windows, it's script/activate. Now, you don't actually have to use the built-in virtual environment manager like I did. You can use any virtual environment manager, but I think it's really important to have a virtual environment specifically just so you can do pip freeze and nothing's in there. It isolates your project to some degree from other projects on your system. So now that we've got that, I'm in the root of my project still, where requirements.txt is. Now I'm in the root of my project's configuration folder, the main folder. It's not actually in the app itself. So this is a little bit different than what I might do for something like Django. Now I'm going to go ahead and do pip install r and requirements.txt. Okay, so if we recognize this file here, this is actually working towards what's called a Docker file. So I'm not going to actually save this just yet, but at some point in this Docker file, we are going to need to run this command. We do it locally. We're also going to have to do it in production. In production, we're going to be running off of this Docker file. This will really configure our environment for us in a sense. It's not actually configuring our environment the way you are doing it on your local machine, but it does it in its own way. Again, I'm not going to be doing that just yet, but notice that I have some syntax editing or showing up the syntax for the Docker file itself. So it's going to show me, hey, this is invalid. This is not a valid Docker file. So that's another reason why I wanted you to install that on your local machine if you could. Okay, so now we have our actual environment set up. So I'm going to go ahead and do pip freeze. And there is all of the dependencies for this project at this time. So let's go back into main.py. And now I'm going to go ahead and actually initialize my FastAPI app. It's really simple. This is another reason why FastAPI is blowing up, is you can do FastAPI like this, declare your app, call it FastAPI, and then do a decorator with app.get. So get is the HTTP method of get. And then we can define home view, and then we can return a dictionary of whatever we want. So I'm going to say hello and world. Okay, so this is a FastAPI application. It's really simple. So to actually run this application, we need to reference this single variable right here. So every once in a while, you might see it as server, but I think from the documentation and also best practices, it's good to call it app. But notice I have a folder right here, or a module right here that's called app. So really I have app, main, and app. So the path to this from the root here is app, main, app, right? So that's actually how we get to this module itself, or this variable. So the reason I say that is because I want to use UVicorn to actually grab that. So app.main and then :app. So app is this main module right here. Main is this main module. And then app is that variable. And then we can do -- reload to make sure that every time I save this, it actually just reloads what's going on. Okay, so I have it running. And if I go here, I see hello world going. Now, you might not have a JSON parser on here. You might see it something more like that. But your actual Chrome can download an extension to show JSON a little bit better. So that alone right now is a REST API endpoint. It might not feel like much of anything, but it is a REST API endpoint. So as it stands, I could totally release this. But for now, I'm going to go ahead and do a little bit more just so we have at least a somewhat functioning website or something ready for this. Okay, so I'm going to go ahead and call this home detail view. And then this is just our simple home view. Okay, so these are two different HTTP methods. So HTTP Git and HTTP Post. Now, if you're not familiar with these, don't worry. We will cover them again a little bit later. But the general idea, the Git method is usually what you see when you go onto a page. The Post method is when you want to send data to any given endpoint. So in this home view, I don't actually want it to return any sort of dictionary like this. I want it to actually have HTML being returned. So to do this, we actually want to implement what's called a template, a Jinja template. And that's something we'll do in the next one. But if you have any questions on this so far, let me know. Otherwise, let's keep going. It may come as a surprise to you that this is a full-on web application. In fact, it's a full-on web application that is a REST API. REST API is an incredibly common way for two applications to communicate. So app to app. Really, like it could be an iOS app to our web app, right? It could be a web app to a web app, and so on, right? We could go down the long list, but basically a REST API is how software communicates with each other, typically through the internet, and it's often referred to as a RESTful API service. So what's happening with FastAPI is every endpoint by default will return back something called a JSON. JSON is JavaScript Object Notation. Now, if you're familiar with Python, what you can actually look at is it's a lot like saying JSON and then dumps and then going in here, but it actually does it all on its own. So feel free to play around with that with your own dictionaries as you see fit. But the general idea is FastAPI always returns JSON unless you change it. And that's what we want to do now. We actually want to change it. We want to change it to using an HTML template. So it looks a little bit more like this, or like this, or like this, than like this, right? So an HTML template is what you're probably used to on the vast majority of web pages. HTML is made for us, for humans. REST APIs, JSON, those are made for computers. That's pretty much the gist of it. Okay, so with that in mind, let's go ahead and actually add in the Jinja 2 package. So Jinja 2 is really just the package name, although everyone refers to it as Jinja. So even if you're on their documentation, you'll see it's pip install Jinja 2. Now, if you've actually used Django before, Jinja is not really different than the Django templating engine. It's just a little bit more advanced in some features in some areas. So that's why we're using Jinja, but also we're not using a Django project. So that's that. Okay, so the idea here is we're going to be using Jinja as our templating engine. We don't actually have to do a template at all. I'm just doing it so you can have a better gist and understanding of how FastAPI works and how you might want to explore it even more. But also with our main index page, the actual home page, what we don't want to have happen is something like this. So if some user accidentally comes here, I want it to actually just at least show something. That's kind of the idea. So the something I'm going to have it show is a Bootstrap template, right? So if you go to getbootstrap.com and then go into the introduction or getting started, there should be an example in here if you scroll down, this starter template. And so this is actually the template I'm going to copy, and I'm going to bring it into a folder inside of my app, and I'm going to call this templates. And inside of there, I'm going to call it base.html and paste this in. Now, the reason I'm calling it base.html is because this is going to be the base, the root of all of my other HTML documents, which we'll see in a moment. And so I actually changed a few things about it off the video that I'm going to paste in here. The things that I changed were I added this style right here. I got rid of a bunch of comments, and then I added this block content here. So this block content is going to allow me to do what's called string substitution, or really block substitution from one HTML document to another. Now, it's a lot easier to understand it once you actually see it in action. So let's go ahead and create a new template here and call it home.html. This, of course, is going to be for that home page. Now, what I want is everything in here. Basically, I want this entire thing like this, right? Except what I don't want to do is have to retype everything. Now, that's what these little block things do here. So we can come in here and I can just say, something like h1 code on, something like that, right? Or I can use some actual Bootstrap classes and just do something like this, okay? Now, this is great. It's giving me a thing that I can replace into another file. Think of these as being combined together, where when I actually do render it out, when I end up making it work, it's going to look like that, okay? So let's go back into home.html. There's a problem here, and that is it doesn't know what other file it should be copying data from or inheriting from. So we use extends base.html, right? Now, if you're familiar with Python classes, think of it like this as my base class, right? And my base class had, let's say, for instance, this data and that data and then custom data. Now, if you create another class called your home class and just leave it empty and say, custom data equals to code on. Now, you still want this data and that data in this home class when you initialize it, right? And so if we did something like this and then obj dot this data or that data, it's going to give us nothing. It's not even defined on this home class. So hopefully you already know what the solution is. That is to bring that base class in. That's essentially what's happening here. It's not exactly like that, but it's close. So this actually overrides what's inside of this block right here, much like what would happen if you were doing the same thing using class inheritance. And if this part is complicated for you with Python, then this is probably not the series for you. Okay, so now that we've got these template things, definitely can talk all day long about these templates. There's a lot to it. I don't want to do that because that's not really the point of this series. If you want to see more on Jinja templates, let me know in the comments and we'll take a look at it. Okay, so now what I need to do is that I need to actually get that template. I need it to be the response here instead of this dictionary here. So in my opinion, this is where FastAPI and Flask start to get a little bit more complicated because it's not actually working the way you might expect. Like I can't just say return render the home.html, with some context or something. This actually does not work for FastAPI. There's several reasons for it, but the main thing here is right now, FastAPI has no idea about these templates. Right? There's nothing in this application that's referencing that template directory. So we need to change that. So I'm going to go ahead and get rid of this right here and just leave it empty dictionary for now. And now what I want to do is I want to import two things. First of all, from FastAPI.responses, we're going to import the HTML response. Now the reason we're importing this HTML response class has to do with the get method here. So what we do is we have to pass in the response class in here, right here. So this actually overrides this response class. So it gives an HTML response now. So what is an HTML response? Well, it's a string like hello world. So we save that. And then let's go ahead and take a look at here. And what do you know? It's now showing me hello world. It's showing me actual HTML. So, I think it would even error out if we tried to send back a dictionary. It might not, but let's go ahead and try it out. Let's see. Looks like it's still running. And now if we go in here, now it does error out because it's not expecting a dictionary as a response. It's expecting a string, the HTML string. Okay. And so what Jinja actually does is it converts these files into an HTML string, but it does it using almost like string formatting. This is something I'm not going to get into right now, but the idea is we want to get these files or one of these files and then turn it into a string and just return that. That's kind of the gist of this. So the way we actually do that is, first off, I need to set up the request. So whenever you need to reference the request on the view, we come in here and say request, is equal to that request class, or of type of that request class. And in here, we can actually print out what this request is, of course. So it's an instance of that request class. We can print it out, we run in here, and we see that there's this request class. There's a lot of information that's built into that, something I'm not going to cover, but the idea is we need to actually bring in the class type itself and then set that equal in here based off of the type that's coming in with that argument. Okay, quite a bit different than Django. If you've used Django, Django just infers that it's the request class. And here we have to actually declare the request class type. Okay, cool. So now we need to actually get the template response set up. So we're going to do from FastAPI.templating, we're going to import the Jinja 2 templates. Okay. And we're also going to import pathlib. I don't need that JSON anymore, so import pathlib here. You can use OS if you're more comfortable with OS. I'm going to be using pathlib. And so what we want here is our base directory. This is really the directory where app is, so we can grab that template directory. So this is going to be pathlib.path, 2_file, and then .parent. So this, of course, is going to give us the path to this file. This gives us that parent path. Next, I'm going to go ahead and say templates equals to, well, the Jinja 2 templates class, and then the directory where we have it. And this is really just going to be the string of the base directory / templates. Now, naturally, we can and maybe should print out what that base directory is, and it should be app templates. You should get the exact same thing that you have set up locally, right? And you could also print out if that exists as well, which is cool. So we could do .exists just like that, and that's a reason to get more familiar with pathlib if you aren't. Okay, so this is a Jinja 2 templates instance, the class itself. And so I can actually come in here and do templates.template response. And this is going to take in which template I want, which is home.html. Now, this right here, the path that you would put in here is relative to the template directory. So if you had it in a folder called ABC, you would put, that in there as well. Okay. So we've got home.html in here, and these template responses require you to pass in a dictionary that at least has the request itself coming in. You can also pass in any other argument that you might want, right? And so that argument itself can be accessed in the template that you're rendering just like that. Okay, so we refresh in here now, and what do you know? I actually have some data that's coming through in here, and it's rendering out that template context. Okay, so just a recap as to what this is doing right here is it's basically opening the home.html file, and then what it's doing is turning that into a string, whatever's in there. So let's just arbitrarily say ABC is in there. And now if we did ABC like this, I can actually call .format ABC equals to 1, 2, 3, and that would actually change that item here. Very similar to like the F substitution as well, where it does change that variable, or it can change that variable too. So it's really just combining a simple HTML document with some string substitution, and that's how you get a template response. So of course we can also look at the request in that template as well. But that's pretty much all I'm going to be covering with the Jinja 2 templates. But it's nice to see that, hey, now I actually have some sort of way to actually render out human readable responses, right? And that's the key. So now that we've got this, it's time to actually move into testing out our project, then going into Git and putting it into production. Whoa. Now, very soon, we are going to be bringing this application into production. Now, before we do that, we want to actually flush out testing to ensure that it's working as intended, so that when we go into production, we don't have any bugs or errors related to the code itself. So to do this, it's actually going to be really simple. First, in requirements.txt, we need to add in PyTest and requests as well. So we'll go ahead and open up a new terminal window. You can still have your server running. That's fine if you wanted to. We're going to go ahead and do pip install-r requirements.txt, and we'll just let that run. You could also upgrade pip if you'd like. That's completely optional, especially in development. Okay, so now that we have PyTest in here, what we should be able to do is write out just simply PyTest, and this should test all of our Python code. Now, in our case, it's actually testing a lot of the third-party code. Now, you may or may not want this to happen, right? So I'm going to keep things simple and remove it for now. So in the root of this project, this is where I will be doing my tests. So I'm going to make a new file in here, and we're going to call this file pytest.ini. And so this file itself is for pytest. And the idea is we don't want certain recursive directories. So no recursors equals to, well, certainly lib. That's going to be the main one, as we see right here. And if you put that star there and then run this again, we should see no test now. The other one, I'm going to also include our bin and include. These are, of course, all of my virtual environment files themselves, just to make sure that I'm not running tests that I don't intend to run at this point. Okay, cool. That's just a simple and easy way to do it. So next, we need to actually create a test. Now, what happens when you create tests is you call it test underscore and then some test name. In this case, I'll just call it test endpoints.py. And the goal of these tests are, well, simply to test the API endpoints that I have. So this is not going to be really that complicated. The first thing I need to do is I need to do from app.main, we're going to import app. Okay, so this is coming from the app module, the main module, and then app, that actual variable. Okay, and then we also want to do from FastAPI.testClient, we're going to import the test client. Now, what this is going to do is we are going to create a test client for this app. And now we can actually treat this just like Python requests. So this is very similar to almost like request.git, or really just requests. But it actually is going to have our app run, right? So let's go ahead and close down our app so we can see this in action. Okay, so I don't have the server running at all. And so I want to go ahead and test one of my views. And again, we'll call it test underscore. If we do not call this function test underscore, it's not going to test it. We'll go ahead and call get home. Okay, so we're testing the get response from home. So response equals to client.get, and we want to go to that home page. Okay, so this is now really the requests.get equivalent. In fact, the response, the actual response class itself, is a lot like that. That's the Python requests package that we installed just a little bit ago. And so what we can do in here in this actual test function is we can assert that the response status code equals to 200, right? So 200 is okay, good to go. That's what we should expect from it. If the server was down, if it was an invalid thing, then we would see a different error. So now we can run PyTest and hit enter. And I get this warning. This has something to do with a third-party package. I can ignore that for now. But what we see here is I don't have any errors, or it seems like I don't have any errors. So let's actually change the test to being, let's say, 500, right? So I'm going to assert that it's a server error now, and I should get something like this. This is not a correct error, right? So it's a 200 status code. Okay, so changing that back to 200, that's all we really need to do. Now, we could break this view as we might want to, but it's not really, I don't think it's great to just break views just to write better tests. But what would happen over time as you write tests is you'll get better at doing it, and therefore you won't have to break your current existing views accordingly. So the other thing I want to test is response. Let's do response.headers of content type. We want to set that equal to text-html. Now, I think this one's actually important because of our get view. We wanted it to be HTML text. So let's go ahead and run our test again. And this time I get something different, right? So it's asserting that it's text HTML, but it actually has a few other things in there. So what I want to do is just say assert that text HTML is in response headers. And now I run that, and sure enough, it is. Right, so we can actually take this same concept and bring it down here and now test the post home. And instead of using the get method, we'll use the post method just like that. And they are very, very similar tests that we'd be doing, but now it's going to be application and JSON as the content type. And we can, again, test it. Sure enough, that's true. Okay, so that's nice. The other thing is I can actually test the response from there. So I can also assert that the response.json is equal to that dictionary, literally the dictionary that was written there. Now, this isn't always going to be practical, but we could at least try it out. And sure enough, there it is. It does 2 tests and we have no issues. So that is PyTest. Now, one of the things that we might also test is the actual template response itself. So what's coming back in here? So I will let you take under your wing. How do you actually create a string? But I will at least give you that you can assert response.text is not equal to, something like h1 hello world, right? So we save that and we can run it. And of course that still runs. So a response.text will at least give you the HTML response. Now I'll leave it to you to see how you can actually render out a template with the correct context and all of that specifically for your tests. Now, if you do find out that answer, let me know in the comments. I would love to see your responses. But the general idea here is we want to test our code to make sure the integrity is there and that when we actually bring this into production, we have a way to run these tests. Before we do anything meaningful with Git and version control, I want my code to test. I want it to happen automatically. And the way we're going to do this is by using a package called pre-commit. So we're going to go ahead and install that, and we'll do pip install -r and requirements.txt. Now, what this package will allow me to do is to define a bunch of hooks or steps that I want my system to take prior to doing a commit, otherwise known as pre-committing. And so what I'm going to do in here is in the root of my entire application where Git also is, I'm going to go ahead and add in a file called .pre-commit-config.yaml. So this is a YAML file. You can also use YML, but YAML ain't markup language. It's like recursive in of itself of a name. In this case, we're going to be using YAML as a configuration file for the pre-commit package because that's what they recommend. So let's go ahead and take a look at pre-commit now with --help. And what we see is all of the different commands that we can end up using. And so the one that should be interesting to us now is this sample config one. So it produces the sample pre-commit YAML file, right? So right there. So let's go ahead and take a look at that with simply sample-config, hit enter. And I'm going to go ahead and copy this from repos down. You could always leave the comments in if you'd like, but I'm going to leave them out. Okay. So this is an actual pre-commit file now, and I can use it. So to use it, we just do pre-commit and install, hit enter, and it installs it for us. Notice the location it installs it for us. We'll come back to that. And then I'm going to go ahead and run pre-commit run -all-files and hit enter. And so since it's installed, what it would actually do is run all of these things. In this case, the fix into files thing failed, right? So I'm actually going to get rid of that one because it's failing on one of these files. So I'm not going to really worry about it in this case. So let's just go ahead and get rid of that. I just really want them all to pass because, well, this is just an example. I really just want PyTest to run, but it's nice to have some of these other things as well. And so now that I run it, it actually seems to fix and run just fine. So let's go ahead and clear everything out and run it again. Cool, we're good to go. And so this is already installed on our machine. So now if I actually run something like the actual commit with Git, so git add --all, that's adding all the file changes, then git commit with the message of, FastAPI Git and pre-commit, I hit enter, it actually runs all of those things. And it's going to do it every single time I commit it, which is really nice. It actually ensures that, hey, at least these things are being handled. Now, another thing that I can do is add in for PyTest. And so what I'm going to do here is I'm going to literally copy this same thing here, and right underneath it, I'm going to paste this in. And so the repo is no longer an actual live repo somewhere else. It's really just our local machine, right? Just like that. The next thing that we want to actually do is get rid of these IDs here. And instead, we want to have a PyTest ID. And this is going to be PyTest. We'll just call it PyTest check. We'll give it a name. So tab over a few times to be right under the ID like that. And then I'll go ahead and call this the PyTest runner. And then we'll give it an entry. So this is simply PyTest, as in what is it that I want to call locally, which is simply just PyTest right there. You could add other things to it, but that's all I want to call. And then we'll go ahead and add in the language. In this case, I'll just use the system itself. And then we'll go ahead and do something called pass file names. And we'll go ahead and say false, and then always run being true. This is an example that I found that's just really simple to run our PyTest. And so let's go ahead and give this a shot. So first of all, I could absolutely run it with git commit, or what I actually have to do right now is I have to install it because I made some changes, and then I want to run all files. And this should actually run everything for me, including our PyTest runner, which is awesome, which we'll test in a moment as well. Now, if you ever get into a place where you're like, hey, well, let me look at this command here. Oh, whoops, we can cat out this and take a look. This is all of the things that are happening in our pre-commit. So, the pre-commit package made a pre-commit hook. We could have manually wrote these things out that would run some sort of script command for us. But of course, I don't want to do that, right? I just want to run it based off of pre-commit. And that's why we're doing that here. Okay, so if we did want to get rid of those, we could just do pre-commit uninstall. That's one way to get rid of that. Another way would be, let's install it back, and then cd into git and hooks, then remove the pre-commit file. That's it. Now it's gone. Now it will not be able to execute those hooks at all. So we go back in here, but of course I want it in there. So pre-commit install and, oops, spell install correctly. And there we go. So now I have that all in there. It's all ready to go. And I'll do that final commit that we're going to do here. And that's git add -- all git commit, give it a message of some kind. And then in my case, I have a git remote already built in here. So git remote -v. My remote is on this repository. Yours is going to be likely on your repository. Now, if you have it on my repository, that's fine, but it's probably not going to necessarily push it like you might want it to, because you're not a collaborator on this per se. You might be, but you might not be. So make sure that your local Git user is right here, not mine. That's kind of the key here. What this is called is completely up to you. And again, if you need to add one, you do git remote add, and then the name you want to give it. Origin is very common for the root remote that you would end up using, like on GitHub or Bitbucket or GitLab. You could also do something like ABC or my server. You know what I mean? You could name it all sorts of things. But in any case, we now have this remote here. So I'm going to go ahead and do git push origin main and run it, right? So in this case, it says everything up to date. Now, in my case, I'm actually working on a branch. So I'm going to go ahead and do git checkout main and then git merge 7end. And now I'll go ahead and do git push origin main, hit enter. And so now all of my new code should be on there. And if I go on the repo itself, sure enough, it all is. And it says 4 minutes ago is when I did that commit because we've been chatting for a little bit. But the idea here is now it has this actual pre-commit config on here as well. So if I ever needed to rerun this anywhere else, I could do that. And also the fact that, hey, where's pre-commit on our requirements? We should probably have it in there and save it. You might already have that, but there we go. We found a little issue. So we did git status, git add, git commit, updated requirements, git, oops. Notice it ran everything. So git push origin main, pushes it, refresh, and now it has those commit things, right? Pretty cool. Okay, so The reason that we do this, or the main reason we're doing this now, is to a couple things. One, to make sure our code is well tested, even though it's teeny. Two, to make sure it's tested when we actually try to push it into GitHub. And then three, to make sure it's ready to actually go into production. So all of the related tests that I would need to do could happen locally. They can also happen on GitHub. So you don't actually have to run pre-commit on your local machine. You can actually run it with GitHub Actions as well as a number of other things too. So it's certainly not something that has to happen, but it's really nice that we can do it locally and get in this habit of constantly testing our code. And hopefully that also means that you're constantly writing tests. Let's go ahead and get this thing into production. Now let's go ahead and jump into DigitalOcean to go into production. So do.co/cfe-youtube is where we're going to be. And then once you log in and get your account set up, navigate over to apps or simply cloud.digitalocean.com/apps. Now in here, we're going to go ahead and create a new app and we're going to click on GitHub. Now, if yours has a little arrow like that, that means you're going to need to integrate your GitHub account. Or if you click on GitHub and you're like, wait a minute, I don't see the code anywhere. Now, my code is right here, or at least it seems like it's right there, but it actually is not, because I'm actually not working off of this user. I'm just a collaborator there in this case, but I am working off of the Team CFE user. So this is actually my user right here. And if I look at my repositories, I see that this one was updated 2 hours ago. This is the one we actually talked about at the beginning. So I'm actually going to delete this one so I don't get confused. You might already have all your code on here, but I'm going to go through this as if you don't already have your code on here. Perhaps you wanted to skip a few steps and you just want to, copy what I'm doing here just to go into production, which is totally okay. So at this point, we can pretend like we have none of our current code on here. So going back into the Coding for Entrepreneurs repos or the GitHub profile, we go into the repositories here and we want to go to the FastAPI microservice. As I'm recording this, this is private. By the time you're watching it, it's not going to be private. And so what I've got here now is I want to actually fork this. If I go to fork it, what this is going to do is it's going to bring it over into my account. As you see, it now says Team CFE over here. So it's going to take a moment for that to happen. And it also tells me where that origin is, which means that I can actually update this later as that code changes, which I think is great. So going back into DigitalOcean, well, that's not necessarily going to show up right away. So if I refresh in here, it might show up right away. It might take a few minutes for it to actually get that new repository in my app platform account, right? Luckily, it happened really fast in my case. The branch we're using is simply main. That's it. There are other branches, but none of them are deployed at this point. If you see a branch called production, that means that I did that sometime in the future. You could totally use that one as well. And then also we want to check auto deploy code changes. Now that since we have the pre-commit set up, right? I think it's safe to say that we can go off of this main branch and auto deploy those changes, because I'm not going to be doing some dramatic things out here that aren't tested and aren't ready. And so when we go here, we see that it detects a Python application. So at this point, we're doing a Python application. If you see main and it's detecting a Docker application, then you might need to change some things in there. So feel free to, maybe use a different branch. The other branch option would be the branch for 7. So git checkout branch, or let's say 7end. So if you see 7end in there and you want to copy exactly what I'm doing, that's where it will detect a Python application. Okay, so now that we've got this, there's one thing I need to change, which is the gunicorn command. I needed to actually use uviacorn. I can use that worker temp directory as it put, but I want to use the -k, and there's going to be uviacorn.workers.uviacorn_worker. And then I want to use app.main:\app. And I don't think I need to bind it to anything, but that's kind of the idea here, is our main app and we want to use the source directory, which is the root folder, same as what we've been doing so far. Okay, so I'll go ahead and hit next. I don't need to add a database on here. We're not going to be storing any data with this microservice. It's just really going to be running functions for us. You can choose a region, any region you'd like, whichever one's closest to you is usually what I recommend. I'll just leave it at New York at this point. And then we'll use basic. And I'm literally just going $5 a month. You can do whatever you like because you probably have that $100 credit. So you could probably put a pretty hefty machine on here, but $5 a month should be plenty, especially as we're testing out a little app like this. And so what it's going to do is it's going to build this. It's going to take some time to actually build this. It happens every single time. It's going to take some time. The reason it takes time is because it actually builds a full-on Docker container, which really helps isolate everything as much as possible. But where we stand right now, it should be able to find our requirements.txt. And let's see here. So we should see requirements.txt in here somewhere when it actually starts installing. Notice it's actually using Python 3.9.4 instead of Python 3.8. We haven't done anything that should not allow Python 3.9 to run. But in case that you wanted to specify which version of Python, you would just change runtime.txt and change it to Python-3.8. Let's see what actual version it is with Python-version, and then 3.8.2. And then you would commit that runtime and send that in, and it would actually change the Python runtime. But notice that it is installing everything that it needs to install, right? Which is great. That's exactly what I was hoping for, and hopefully you are as well. Now, in the case of this particular application, the installation process should not take that long because there's not that much to it. There's not that many requirements, and there's not very many integrations, but it still can take some time. So I'm going to let it finish, and we'll come back. One thing I did want to mention, though, is if you were to push this into production, let's say if I did git status and then git add and then git commit and then updated Python runtime, and then we push this into production, like git push origin main, or at least pushed it into the repo, DigitalOcean will automatically try to rebuild this. So it would actually cancel this deployment and then automatically rebuild a new one, which may be something that you want. This is another reason to be testing our code frequently, right? So we want to make sure it's well tested so I don't have to cancel deployments while they're happening, because this build time, it just takes a few minutes. That's, it's not super fast to get back up and like fix a bug that may have been avoided because you ran some tests. Anyways, let's let it finish. Okay, so after a few minutes, it finished building, or maybe 10 minutes total. I don't know. It definitely took some time to finish building. So I'll refresh in here. And it's certainly possible that my run command isn't correct. So let's give it a shot. I think it will tell you if the run command's incorrect. And what do you know? There it is. It's actually working correctly, and it says code on. Not really that exciting of an application, but you know what? It is in production. To me, this is one of those things that's like so exciting, so I can just keep going. So naturally, the next thing is we actually need to set up our environment a little bit better to actually use the OCR machine learning algorithm that we need. And that is why we actually need to use Docker. I'll get into that more, but for now, we've officially deployed our first FastAPI microservice for Django on DigitalOcean. One of the downsides to deploying code like this and the way we just did is the lack of being able to control the actual operating system environment. We have the requirements.txt, and this sort of helps us with the environment, but it doesn't actually do it on the operating system level. This is just Python packages. So what we're going to do now is we're going to deploy a Docker file, just a Docker file, to App Platform to actually handle this. Now, if you're interested in learning Docker, I highly recommend it. It's a really interesting tool, but it's outside the context of what we're covering here. I do have a full series on it where it really goes in depth on how to use Docker and another tool called Docker Compose. But really the key thing here is we're going to be deploying to App Platform again in a very similar way to what we just did, except we're going to add another file to it. Actually, two new files. Now, we actually already did create a Docker image. That is exactly how App Platform works when you just deploy code, it actually creates an image for you, as you can check by the logs of the project you just created. Now, I did some tests, so I actually had to rename the project, but the idea here is we want to re-engineer a lot of the things that build into this Docker image. So let's go into that project that we just created, which in my case now is just FastAPI-MS, but yours might be FastAPI microservice and all that. But anyways, we want to jump into the settings and go to this component. I'm going to scroll down here and look at this run command. I actually want to keep this run command and I want to bring it in locally. So in my local project, I'll go ahead and create a file called entrypoint.sh. So I'm actually going to paste this in here. Now, the reason for this is because I actually want to make sure that when I use Docker, it's going to still call this same command. That's actually why we have the command in here in the first place. So this is actually going to be called inside of a Docker image. But I like doing it in an entrypoint.sh, like an actual shell script, so I can test this locally if I needed to. So the other thing is I want to actually put in the hashtag !bin/bash. This is just telling the shell that this is a bash script, so you can run it as any normal Linux script. The next thing is we're going to do /usr/local/bin and then gunicorn. So hopefully what this tells you is like we're going to be installing gunicorn on the local user inside of Docker. You might have no idea what that means, but basically this is going to be system-wide. It's not going to be a virtual environment like what we did here. Now you totally can do a virtual environment. It just takes a few extra steps, something I'm not going to cover right now. Next, I'm actually going to bind this to a specific port. So the port I'm going to bind it to is we're going to declare it as a run port, and it's going to be just like this. And I'll explain this in a second. And then we'll grab that variable and do --bind and 0.0.0.0 : curly brackets run port. Okay, so this variable here, I can actually use at any time. I can change this variable based on another environment variable of port. This environment variable, I believe App Platform will actually set for you. If it doesn't set it, then we get 8000 as our port, right? So this is kind of giving me a backup port. And this is just a way to do that string substitution to bind it to 0.0.0.0. Now, this actual IP address is just so it can attach to any other IP address. That's really the key thing there. Okay, so that's our entry point. Now, unfortunately, I can't test this locally in my current environment because I don't have gunicorn installed in my local system, right? And if you're on Windows, it certainly won't work because that's not how the Windows file system works. This is specifically for our Docker file. So we can test Docker files locally and do all that stuff. But again, that's outside the context of this one. And that's why I recommend you check out this project if you're interested. But now that we've got this, we need to create our Docker file. So this is going back to what we saw before. Now this takes a few different components to it. So first off, we say from, I'll come back and fill it out. Then we do copy, then we do run, and then we do command. Okay. So the first one, the actual easiest one for us right now is command. The very last thing that we want to run is entrypoint.sh, right? So that's that file that I literally just created. No big deal here. So what are these for? Well, this first one is from. Now, this is kind of like saying what other pre-existing Docker file or Docker image do you want to use? That's probably incredibly confusing. I think of it more in terms of, hey, which operating system do you want? Or which programming language do you want? In our case, we want Python. Now, Docker has official Python images. It has official Node images as well, and many, many other official images. But we're going to go ahead and stick with Python. Now, what is the version of Python we're using in our virtual environment? And that's 3.8.2. In this case, I'll just go ahead and say 3.8. Now, I can leave it like this, but one of the goals of using Docker is to make it as small as possible, as in you don't want too big of an operating system in here. So think of this Docker file as creating our operating system. So we'll just do -slim. This is very common as well. There's many other ways to optimize Docker files, but I'm just going to leave it as is. Next, what are the actual local files that I want to bring into production? Now, the files that I want are for sure that entrypoint.sh, and I'm just going to put it into the root of entrypoint.sh. So the actual root of the Docker image itself. That's completely fine. Next, what we're going to do is we're going to go ahead and copy, well, I want to grab the app itself. So app into /app. Okay. So the local app, that's this folder right here, into another folder called app. Now, if I said ABC here, then all I'd have to do is in my entry point, I would have to update this right here from app.main to abc.main. But of course, I'm going to keep it in as app. Okay, and this also in as app. The next thing is I need to make sure that I'm bringing in my requirements.txt. So copy and requirements.txt to requirements.txt. Now you might be like, well, what if I just did copy like this, right? What if I just copy this whole directory? Generally speaking, that's okay. And actually, since we're using Git, you could probably get away with it. But the problem is if you did this locally, if you did it somewhere else, then it's going to copy all your virtual environment stuff. There are ways around this. There's a file called a Docker ignore file, but that's not something I'm going to cover right now. I'm just going to leave it in just like that. This will give me the general aspect of the things that I want, and then I'll also put it in copy like that. Now, another thing you might see on Docker files a lot is a working directory, and it might be into the app itself, like this, the actual destination app. And if you did something like that, then yet again, I'd have to get rid of .app or app dot really in my entry point. That is basically saying, hey, jump into this file or this folder right here. Again, it works, but it's completely up to you on whether or not you want to go that route. I'm going to keep it as close to as my local development environment as possible. Okay, so hopefully at this point, it's not that complicated as to what's going on. Hopefully. Maybe it is, maybe it's not. Now I can actually run python 3-m pip install -r requirements.txt. Now the reason I know I can run this is a couple reasons actually. One, we are using Python, so I for sure have Python 3. Whatever in there. In this case, it's 3.8. Then Python 3 has a module called pip installed often, not always, but often, and we can actually run requirements.txt, or at least that would be the working theory. Now, unfortunately, this won't work right off the bat, not with Docker files and not more specifically with Linux files. So with Linux, what we often have to do is set up the environment even more. So it's common to do apt-get and then install as well as update. So we start off with update and then we run our install commands. So apt-get install, and then we'll do -y to just say, yes, we want to install all of these. Now there's a few that we need. Okay, so the first one is build essential. The next one is python 3-dev, and then a slash. This slash right here is just basically chaining these all together as one big command. Next one is python 3-setup tools. And then we're going to go ahead and do Tesseract-OCR. There is the key for this entire project. This is why we have a Docker file, is specifically for Tesseract OCR. I think a few commands that we need in order for Tesseract to work are make and gcc. So after we do all that, then I can run this python 3-m pip install requirements.txt. Now, if you're familiar with Python, you might also get away with pip 3, but I'm just going to stick with python 3-m pip install. So all of these commands right here, if I were to actually go into a Linux virtual machine or a Linux machine of any kind, even a Raspberry Pi, if they were all run by themselves, you would absolutely get this stuff installed correctly. And it's literally, you just don't have run in there. You would just run the commands like that. And often you'd have to do it as a sudo user. But in this case, this all should work. Now, there are a few other commands that I'm going to add in and just copy and paste these. And these are pruning commands, right? So I'll put another slash here and chain it together with these. So simply removing the things we don't need after we run all the installations, then removing anything else and everything else that we might need to prune, again, to make this image as small as it possibly can. So that's really configuring our environment. Now, in some cases, you might need other packages. It really depends on what system you're working on. This is a way to do it, right? Now that we have this, there's one last thing is I want to make sure that my entry point is executable. So I'll just do run and chmod +x entry point.sh. Okay, so we now have our official Docker file. It's ready to go. So what I'll do here is I'll do git add --all git commit -message, and we'll just say 9, and I'm only calling it 9 because this is part 9, and it's deploy Docker app to DO app platform. Okay, and in this case, it actually gave me a failure on my trailing white space, which is kind of funny. So I think it fixed the Docker file. So let's go ahead and try that again. Oops, I need to add it. And now run it. There we go. Okay, cool. So it fixed my Docker file for me. Yes, love those pre-commit commands. Okay, so now what I need to do is actually push this into my origin. So I'm going to do it git push origin main. Now I want you to notice that I'm using 9-n. I actually want you to stick with that branch too. If your local branch is different and you pushed it to your origin, that's fine. But now I actually want you to follow along with me so you have exactly the same code as me and there's no issues whatsoever. There might be issues because that's why I'm recording this the way I am. It's because there were issues on my end. Okay, so I'm going to jump into my project here and I'm going to look for branch 9-end. Okay, so notice it's not there yet. So let's go ahead and push it in. So git push origin 9-end. Okay, so now in here, I should have it. And there it is, 9-end. And so on my local project or my local user where I forked this already, right? So if you hadn't forked it, fork it now. Now you should fetch upstream if you didn't already. Like if you just forked it, you won't have to do that. If you forked it before, you'll have to do that. But you can do this at any time if it needs to be forked. Next, we're going to go ahead and scroll down. We just want to verify we have 9-end in here. And it looks like that part did not come. So let me just refresh in here. And 9-end. Yeah, so I'm not seeing that branch coming through, which is odd. Let's go back. Yep, sure enough, it is definitely there. Okay, and so 9-end, nope. Still, I think maybe the caching issue is in here. Perhaps that's it. So let's search here too. No. Okay, so I'm not finding the branch. Really simple solve for me at this point. You will definitely find the branch because of where you're watching this. You're not watching in real time like I am. I'm going to just go ahead and delete this and go back in to that branch or that project itself. And I'll fork it all over again. Okay, so this actually won't break my other application, right? So the reason it's not going to break it is because the repo itself has not actually changed, the source repo. Even if it did break it, we're learning you could always delete things. You could do a lot of stuff to bring us back to where we need to be. But now if we look in these branches, we should see it. And sure enough, there it is. Now, this is all because of now what I want to do is go back into App Platform and we're going to create a brand new app here. I'm actually not going to add anything to my other app because we don't want to cobble things up in there. You could totally delete the other app, but I'm going to do it in here. So FastAPI-microservice for Django, find the branch that you want. You can certainly auto deploy code changes if you like. I am not going to be working on this branch any longer. In fact, I'll be working on the main branch. So depending on when you're watching this, the main branch will have all of this code as well. So let's go ahead and now hit next. And so this is going to detect a Docker file. So it's going to automatically go to the Docker file. It certainly detects everything else, but it automatically goes to the Docker file. And so we've got our HTTP port in here, right? And notice that it says your port env var is being overridden by this setting, which means the environment variable port, whatever you put in there, this setting is going to change it. And that's also why I did this, is so I can actually go off of whatever that port is and place it in here. But if I need to test at any time, I can decide whatever port I want. That is a critical feature, which is why I put it. Okay, cool. So now that we've got that, let's go ahead and go to next. And we're just going to make this, FastAPI and Docker. Okay, and next. And then come in here, $5 a month, launch basic app. Okay, so it should just take a moment before it actually creates it. While it does that, I'm going to go ahead and search FastAPI Docker. And what I'll see is there is an actual guide to deploy with Docker on FastAPI's documentation. But what you'll see is this, right? So this looks nothing like ours. This is because the creators of FastAPI have their own Docker image, their own image that you can actually copy from to shortcut all of the things that I wrote here. This right here is like the longest it probably will ever be for you when you're deploying Python applications, unless of course your operating system needs more than just the Tesseract OCR. But the cool thing is, now that you have this, you could deploy it to Docker Hub and have your own version of this. But you could totally work off of theirs as well. So instead of using the Python that I did, you could totally do that exact same thing and it would still work roughly the same. It's a different version of Python, which still should probably be fine where we're at. But the general idea is Docker is incredibly flexible with all of those things. Yet another reason to learn it. But anyway, so now what we're going to do is just take a look at the build logs. So I've had experiences with deploying my first Docker images to App Platform where the very first build does not work, right? And then the second and every build after that does work. So when in doubt, especially when it comes to App Platform, you're going to want to every once in a while force build, rebuild, and deploy and clear the build cache. This is really good to do from time to time. It takes longer to do the build, but it's really valuable when you're running into issues related to the build. I'm going to say it again. What another thing that would be really valuable is to actually test out the Docker file locally, and learning how to do that would be really valuable as well. But you don't have to, right? So what I did so far is, I think, fairly straightforward. It's just another file. It's just like requirements.txt, but now it's for the operating system. It's almost like os-requirements.txt, and it's just in a certain format that might seem a little weird at first, but I think it's pretty intuitive once you actually start using it. And Docker does get more complicated than this. I think this is like on the easier side of things, but I would also argue that like 90% of the things that you might end up doing is related to this, unless you really get into, managing Docker deployments. Maybe it'll be a little bit more complicated than that. The other cool thing about Docker while this is building is it actually will set you up for using something like Kubernetes or many other services that really run off of Docker because of how it isolates the environment better than anything else. And it's really flexible. It's not stuck to just Python. It can be anything. Requirements.txt is for Python. Package.json is for Node.js packages or JavaScript packages. So that's another cool thing. Now, I do know that these builds will take anywhere from 5 to 10 minutes, maybe even 15 minutes. It really depends on how long their service is running. So I'm going to go ahead and pause this and we'll come back once it's done. Okay, so 6 minutes of build time. It's actually a little bit faster in my experience than the other way of deploying. And if we look at our details here, I don't think I see anything that really breaks what's going on as far as the build logs are concerned. But one of the things that you can notice is if you scroll up a bit, it's going to tell you that a bunch of packages will be removed. It's going to tell you that some packages should be removed, right? So there's a lot of those commands that are sort of necessary for it, but it also shows you that it's installing everything that you need. Now, my deployment logs, it looks like everything's working correctly. So let's go ahead and open this up with the correct port. So I'll go ahead and open the app here. And what do you know? It's definitely working with the Docker deployment. Now, the other cool thing about this is when we want to use the actual deployed version of this, we can go into the console for this actual project. So if we list it out, there is the result of everything related to our Docker deployment. So everything in here. So notice copy app, there's app, right? Entry point, requirements.txt. So certainly those things can be in different places, right? So perhaps it would be better in the long run to do something a little bit more like this, so it's not cobbling up anything else related to the project itself or the entire, right, the actual environment itself. But as you see, it's working. So we don't really need to worry too much about optimizing the Docker side of things without really using everything else. So the other part of this is what I haven't installed yet is the Python, like any particular Python package related to OCR. So we can actually run pip install in here. So we can do pip install, let's say, let's do something that we definitely don't have, which was Django. So pip install Django, and what do you know? It's going to install things. However, don't get fooled by this because this is installing it on a Docker container that is ephemeral. That means that it's going to come and go at any time, right? You may or may not want to install things on here. The reason I use the console is to test the installation, test things out in an actual Docker container versus trying to get it locally all the time. This is one way to sort of circumvent working on it locally. And so another way to think about this too is to go little by little adding things, not necessarily doing it all at once. The reason we're doing it all at once is because, well, we want to get this Tesseract OCR working as soon as possible. So let's go ahead and go back into the Python code. So at this point, we have two different environments. One is our production environment. One is our development environment, what we see here. And of course, the production environment is on DigitalOcean. Now, the idea here is we need to think about this code in two separate ways. Actually, we need to treat it differently, as you might imagine. So what I want to do here is I want to have something like debug being true if it's in development and false if it's in production. So how do we actually go about doing this? Well, first and foremost, I can add in an import to OS and do os.environ.get, maybe like debug, and we can set that equal to maybe the string of 1, right? So that would also mean that I should probably put this in as a string as well, just like that. So how do we actually have debug work? Well, I'm going to show you one way, the way I don't recommend first, and that is literally writing out debug equals to that, and then uv app.main :app, and then -- reload, hit enter, and in this case, it will give us that debug, okay? And generally speaking, this is fine. Like I can absolutely do this, but then I have to remember when I am local, I have to remember to switch that from on or off, right? Or other words, if I actually run it like this, now it's going to say false. So I want all of that to happen automatically. Now, in order for this to happen, we have to introduce several new things. They're not really that complicated, but they are useful. So we'll go ahead and import from Pydantic. We're going to import the base settings class. And then I'm going to declare my settings class as the base settings. And now I can actually have that debug in here as a Boolean type, and we can set that equal to false by default, right? So this class here is essentially doing this same thing. It's just slightly different. And so what I do is just say settings equals to an instance of that class, and then I can just come in here and do settings.debug. The nice thing about this being lowercase is it does match the debug environment variable still, all caps, which is typically done for environment variables. But we can actually take this a little bit further and we can actually base it off of something else, which is a .env file. So if you do env file like this, and then do .env, this is now going to look for an env file inside of our project. So if I do .env here, I can now say debug equals to 1, right? I don't actually need the string here, but generally speaking, this is how we would do that. Now, in order for this to work, if I actually restart it, it's probably going to tell me that I need to install python.env. So make sure, if you don't have it already, make sure you do. So python-.env, just like that. There is a Django one, just be aware of that. This is the Python one. And of course, I definitely want this in my requirements.txt if I don't already have it. Okay. And so the reason for that has to do with our environment variables to actually use these. Now, according to the documentations on FastAPI, this is not the most efficient way to initialize these settings. So I'm going to introduce the most efficient way, and that is by importing func tools. We import something called LRU cache. And what this is going to do, it's a decorator that we will define over something like git settings. And then we want to return an instance of that settings. So this function here and this decorator will mean that it's only called one time. So it actually caches the result from that, which is completely fine for us. That's really all we need. And the use case of the actual settings themselves inside of any given view is actually handled just slightly different as well. And that is, we bring in a depends class in here. And now what we do is add settings, the result of this, as an argument inside of our view, much like we do with our request. And this is of data type setting, like that, not initialized. And of course, that's going to be equal to this depends class, and then it's depending on this function right here. So this is now a view that's handling these settings, and it works like all of the other classes you might use in your project anyway. And so the idea then now is every time I need to use settings on any given view, this is what I want to do. And of course, moving this into other modules is certainly encouraged. So now if we look at debug here, how do I actually handle this portion? Well, in this case, I actually wouldn't leave it as a configuration on main.py. I would literally only use debug where I need to, and I can still call this get settings method here, right? So if I call it up here, we should still get that value, get settings, then .debug. We should still be able to get that value from there in the first place. Oops, we have a little error here. This should be from func tools. But anyway, so now we've got that false in there, right? So it seems like it's not actually handling it correctly, right? In the sense that, hey, I've got debug in here as 1, but this is saying false, okay? So if we go back into, let's say, our home view, and this time I'll go ahead and print out settings and debug. So let's go ahead and actually navigate to our home view here. Just going to restart the server and open up this page. Okay, so it's still saying false. Now, why is that, right? So we've got the problem right here, and this should be env file, not filed, and now it's doing it. Okay, cool. So two different ways on how you can actually still use those settings, and this LRU cache will just make it efficient. That's it. But overall, what I would actually end up doing with this is saying settings equals to get settings, and then settings.debug, like that. Pretty cool. Very simple, but definitely something I'll use in the near future. Now we're going to go ahead and handle file uploads in FastAPI. So it's going to be very similar to our post method here, except it's going to take in an argument for the actual file that's being uploaded. This is probably not that surprising, but what I want to do is also return that file. So I'm essentially echoing this file, and I'm going to call this the image echo view, and I'll just give the path of img-echo, and that's it. Okay, so how do we actually implement this? Now, first off, let's focus on the input itself. And so the input is going to be based off of a file class. So let's go ahead and actually put in some parentheses around this and separate these out because we've got a lot of imports now. And so we're going to bring in the file class itself as well as the upload file class. And so what we want to do with our input, the actual upload itself, is going to be based off of this, and we'll give it a upload file type. And then it's going to be equal to the file, and then using ellipsis, we'll give it an arbitrary length of whatever that file would end up being. And so this is now going to be our file. But we have one problem, and that is how functions end up working. Well, we could actually load this function, but it's going to load asynchronously. So we have to do async and then the function name. And now we're going to want to get the actual bytes. So we'd say bytes, or actual file bytes, is equal to await file.read. Okay, so those are the actual file bytes that we'll end up having. Now, using just simply bytes is really not that valuable to us. So what we want to do is import IO and turn it into a byte string. So this time I'm going to give it a byte and string, and this is going to just be io.bytes IO, and then grabbing that byte string that's coming through right here. So now that we have a byte stream that creates a byte string, we're going to go ahead and actually save this file somewhere at some point, and then we'll return it. So before we even save it, what I want to do is set up a place to save it. So we already have our base directory here. And so I'm going to go ahead and currently use a uploaded dir, and I'll give it based off of this base directory, and we'll just say upload or upload it, either way. Okay, so now that I've got that, I have a destination in mind. So the destination is going to be that uploaded directory, and then what else? Well, what I could do is I could actually use the file name itself. So whatever is being passed in with this file, I can use file.filename. Now, there actually is a downside to doing this, and that is, what if I upload the same file with the same file name over and over and over again? Well, to solve this, we're going to use pathlib and another package called UUID. So import UUID. Okay, so this package itself, now what I'm going to do is come in here and say fname equals to, well, this file name. So pathlib.path of that file name, just like that. And what I want here actually is the suffix. So I'll use fext equals to fname.suffix. This will give me, .jpeg or .txt or whatever, right? And then the actual destination, what I'll use is a string substitution variable here. So uuid.uuid1, and then dash, or rather not dash, but just fext. Now, if you've never used UUID1, it's a UUID with a actual timestamp as well, which is really nice to add to the actual file name. Granted, it's going to be stored when it's actually created as well, but it's also nice to have it actually in the file name so you can parse that a little bit easier. So now that we have this destination here, let's actually save this. Now, you might already be familiar with open and the string of whatever the destination is going to be, and then WB as out, and then out.write, and then this would be the actual byte string itself, and then we would read that. And then this would actually save it to that destination so we could return back that destination. Now, the thing about this is, if you remember back to our template here, we actually had an HTML response. This time, it's not a JSON response, which is the default, which is what this is. And it's also not an HTML response, but instead, it is a file response. And so we'll go ahead and implement that one. And that's simply just response class is equal to that file response. Cool. So I'm going to get rid of some of these print statements and comments. There is still another thing. Now, this is nice and all for local environment testing. Now, that's actually the key here, is I'm making this for just testing what our upload view would end up be like, right? It's not going to be our actual upload view. It's not going to be our actual prediction view at all. It's just a test. So since it's just a test, we need to add in one more thing into our environment variables, and that is going to be echo active. And we'll set this equal to a Boolean type. And we'll give it a default of false. So echo active, of course, in here, we could say something like this: 1 for true, 0 for false. And I'm going to go ahead and just say echo active like this. And so that will infer to this same variable. Definitely check it out and try it out on your own if you don't believe me. But now I'm going to go ahead and also copy in these settings here and bring it into this file. And really what I want to check is if not settings.echo active, then I want to raise what's called an HTTP exception. Now these are pretty common and something that you will certainly use later because we definitely need it in another view. So we'll do HTTP exception as an import here. And we're just going to bring this in and raise it in and give a detail being that invalid endpoint, not really not found, but just invalid, and status code being 400. Okay, so now when I go into production, I will have a lack of response. So this file response just simply won't happen unless I change the environment variables. So that's pretty cool. Now I could also add a header, which is something we certainly will do. But the idea here is we now have a way to actually upload files. This also means that we need to test this. So that's something we'll do in just a moment. But just to recap, whenever you're actually uploading files, you want to use an asynchronous view. This is why we use uviacorn as well. So if we look at uviacorn and app.main app and then reload, uviacorn actually is set up and ready for asynchronous views and asynchronous web server gateway interface. And that's also true for this uviacorn worker inside of gunicorn. So both of those things together really allow for an asynchronous view like this to work on a web application, which I think is really, really cool. But we're actually missing a couple things for this view. So what I need to do also, let's just open up a new terminal window here and activate our virtual environment. I need to go ahead and do pip install -r requirements.txt. And of course, I need to add in some new requirements. Those are related to uploading. And we would see this error happen if we actually ran a test yet, but I haven't ran that test yet. So I'll just do AO files like that and then python-multipart like that. Those are two that we'll definitely need. And then we'll also need Pillow eventually, which is the Python image library to actually verify proper images being uploaded. So go ahead and add those and save it if you haven't done that already. Okay, cool. So now we have this directory for uploads. It's time to actually test our uploads themselves. Now let's go ahead and create an automated test for this endpoint. And I actually added in a couple images in here just to test the file uploading purposes here. Now, of course, this isn't an actual image check yet. There is no image validation, but there will be. For now, I'm going to go ahead and jump into test endpoints, and I'll copy this test post home, but instead, of course, changing it to our image echo view. So image echo with that trailing slash, right? Just like that. Okay, so to actually post a file, it's simple. We say files equals to some file argument here, and then we're going to open up a path, and we want to read bytes. That's it. I'm going to get rid of the notes there. Now, what is this path going to end up being? That's really the question here. We'll do that in a second, and I'm going to call this test echo upload. Okay, so the path itself is going to be based off of these images. So what I want to do is inside of my imports, I'm going to go ahead and import the base directory from main.py. Of course, it's that right there. I could also declare that, but just importing the base directory makes things a little bit more simple on here. And so the path itself is going to be equal to, one of these files. Now, there's many different ways on how we could go about doing this. So if I say images, this, of course, is the image directory. And what I can do is I can actually put all of this in parentheses and do a glob and say star. That will literally get every file that's in here. And then if I put all of that around a list and then save up to 1 or something, then it will allow me to use that specific path. But what would be better is if I actually tested all of the items that were in here just to make sure that they're all working. It's certainly going to take a little bit longer, but it is something that I think is well worth doing. So instead of doing that, I'll go ahead and say image saved path, and we'll give it the base directory right here. And then we'll go ahead and iterate through for path in image saved path.glob and everything. Then we're going to go ahead and push this through. Get rid of this. So the other thing is you might actually want to only test PNG images. That would be a way to do it. Or TXT images. Yet again, another way to do it. And so in this case, it's just simply every file that's in there, because the other thing is we could always put in a text file in here to verify later. And so the response type should not be application JSON, but let's go ahead and give this test a shot. So we'll go ahead and do pytest and -s so we can see any printout that we might need. And I got an image save path is not defined. Now we have the error, no such file or directory. So what we see is if we investigate this path right here is what we need to verify. And my suspicion is that we actually stored the uploaded file in the wrong spot, which is actually where this error is happening. And so we can actually go into that function and take a look, right? So let's go ahead and jump into main.py, scroll down, and this is actually where the problem is. And so my suspicion is upload dir, right? So whatever that directory is, I need to check it out. And so if I scroll up a bit, what I see is my upload directory says uploaded. And so if I actually change this to uploads like this directory right here, then it should actually work. And so I'm going to go ahead and also do upload dir.make dir or mkdir exist okay being true. Now the actual reason for this is also to delete this after we run our tests. So inside of test endpoints, I'm also going to do import right above FastAPI. We're going to import shutil and also import time for 2 reasons. But after these tests run, I'm going to do shutil.remove tree, and that's going to be that upload directory. Okay, so I'm not going to do that yet, and I'll also do time.sleep so we can make sure that this is all happening. I'll get back to that in just a moment. But now that we fixed that upload directory, let's go ahead and do a quick test. And now we get another error saying assert application JSON is not in image./png. So in other words, this error is failing. No surprise here because it is an actual file. So instead of asserting these, what we can do is take a look at the actual response headers to see what's actually coming back from this request. So we run this and hit enter. And sure enough, it does pass. Make sure you use that -s, otherwise you won't see those print statements necessarily. And so here is the headers that are coming back. We get content type, content length, which means that it's actually content, like it's a file that's coming back from it. And it's an image and a PNG image at that. So this is cool, and it actually allows us to do a couple things. Number one, I can now test path.suffix. So if I actually run this now, what I should see is .png, right? So what I want to do then is check that if this path is in this content type. Now this is not always going to work, right? So not every file will do this, but the files I'm testing, it will. And also when I go into images, all images should actually validate in this same way. What I mean that is I'll just do image ext, or let's do fext to keep some consistency here. I'll do path.suffix, and then I'll put this into a string just to verify it is a string. And then we'll do replace the period with just an empty string. And now what I want to do is just check, we'll assert that that actual extension is in response headers content dash type. Okay, so now it's based off of that path. So it certainly should be, right? So I'm going to get rid of these now, and we'll run it again. And this time I've got, oops, I shouldn't have deleted ftext. I should have just deleted those print statements. There we go. And so now what we should see is valid all the way through. Now, this is okay for what we currently have, but it's not great in the sense that it's not actually testing an image, right? So it's not verifying any image in here. It's also not verifying that it's sending an image back or the exact same file back, in other words, right? So right now, this should be echoing that same file back. But we can certainly test more things related to that if we really wanted to get nuts. I don't want to get nuts yet. Instead, what I want to do is implement this right here. So we're going to go ahead and implement time sleep and shutil remove tree of this upload directory that we still need to bring in. Now, the reason I'm doing this right here is because this test echo upload is a temporary thing, right? We don't actually want to keep this upload directory forever. We only want to keep it when we are doing this image echo. In fact, when I go into production, when it's actually in production, we won't save those images at all on our local machine. A big part of that is because of the Docker file. I'll talk about that again when we get there. But for now, I can actually see these uploads. So all of them are here from all of my tests. But now let's go ahead and run it now with some sleep in there. So it's going to take a few seconds. It's just going to show me the new ones. And then that whole thing is gone, right? And so really, when I'm running my tests, I don't want that at all. I just wanted to run those tests, put it into that temporary directory, and go. Now, the reason I'm not actually using a proper Python temporary directory from temp file is because if I ever do want to see what's being tested, then I could just either sleep it or comment it out again and see what the actual values are. That's a big part of the reason I'm doing that. So this make dir's file or folder actually probably should exist in here. So it shouldn't always make this directory in here, but rather do it on the view itself during the testing phase, or really during the echo active phase. And so yet again, there we go. Now it's gone, and it literally will not come back up until we run that endpoint again. The final test would be actually changing this to 0, the active being 0. And this time it should give me that status code. Now that's not something I'm going to implement at this point. We will actually test the live echo version later. But for now, we're going to just test it just like that. So just our local environment tests, they're all set up and ready to go. Now it's time to validate the actual file upload itself as an image file. Now what we need to do is implement the Python image library to validate our upload being a proper image. So to do this, we're going to go ahead and go to requirements.txt, add in pillow, make sure that's in there if you don't already have it in there. And then back into main, we're going to go ahead and import. We'll go from pill, import image, the image class itself. And so now into our echo, what I want to do is I want to turn this byte string here into an image itself. So we'll go ahead and say image, or image equals to image.open. Let's actually call this img. And we're going to try and open up that byte string. So this is actually how you'll do that. Oops, we need a trailing parentheses there. But this is how you'll do that, right? You'll actually attempt to open an image there. And then instead of actually using the open bytes and all that right here, we can just do image.save and then change the path to whatever that destination is. That's kind of why I actually used open and all that in the first place, is because I knew I was going to end up doing this. Okay, so now we can actually manipulate this image in here as well, right? So that's another thing. The Python image library gives me a lot of options to manipulate an image, not just validate that it is an image. Now, it's not always going to work perfectly, right? So there definitely is challenges that could arise using the Python image library only. So you could also consider using OpenCV, also known as CV2. So OpenCV would be another option here. I'm just not going to cover that right now. But anyways, so now that we've got this image, we want to test all of this out, and we should have no issues with the test right now. So if I do pytest-s, it should work just fine. But that doesn't really tell me anything, right? It's kind of false confidence. In fact, in my image folder, what I should be doing is creating something else. So not an image.txt and say hello world, right? So now that we've got a non-image in there and we try to upload this, now I get this unidentified image error, right? So in other words, if this can't open the byte string, whatever it is, I'm just going to assume that it's not a valid image. Even if on your local machine it's supposedly a valid image, I'm going to assume that it's not, and they'll just have to reform it. Now, I'm actually using this as a microservice, so it doesn't really matter to me if I did that, right? So like as an end user, you might be like, hey, what the heck? That isn't a real image. Why is it saying it's not? But since it's a microservice, I can worry about the actual image part later, like actually in the other service, not necessarily this one. This one's going to be a little bit more strict is kind of what I'm getting at. So with this, I'm going to go ahead and use this exception again, and I'll go ahead and put it into a try block and do accept. And then this time, this will catch every possible error that happens with this. Now what I'll do is just say invalid image. And that's it, right? And so this one now would give me an invalid image on one of these items, right? So inside of my actual test, it's doing it correctly. It's giving me that error response. So this means that my test itself needs to be improved a bit, right? And so that is, I'm going to have to, maybe update how my actual iterations are coming through. Or I could change this ordering right here and really look for what this is. And I could say, just let's go ahead and say valid image extensions equals to PNG, JPEG, and so on. I'm not going to end up doing this. Don't worry. In the long run, this is not how I'm going to be testing it. But I'm going to go ahead and do this and say that if the extension is in here, so if that FEXT in here, and that is essentially what we might end up doing. And this would actually solve that test, right? It does solve it, but it's not really solving it, right? It's not actually validating that that image is incorrect or correct. So you might have some sense as to what I could do here. Maybe not, but it actually has something to do with Pillow again, or the Python image library. And that is to actually import it. So we'll go ahead and do from the Python image library. We're going to import the image itself. And this time, I'll go ahead and say, try the img equals to image.open and path. Otherwise, we'll go ahead and accept and say img is none. This is a much better test. We would say, basically, if img is not none, then we'll run these. Otherwise, we'll go ahead and assert that the status code is 400, right? Because this extension thing is not reliable. And what's actually better with this test now is it's actually testing how the view itself is functioning, at least in terms of the image itself. It's actually not testing the response at all. That is something we do want to test as well. So let's go ahead and run this. And now I got, ftext is not defined. Let's get rid of this right here. I'm not going to test that extension thing anymore. And so now we've got the valid responses or the valid tests altogether. Okay. So now what I want to do though, is I actually want to test the image itself, the response image. So what I'm going to do here is I don't need this try block anymore. I shouldn't have to have this try block at this point. And I have image being none. So if this path is not an image, we aren't going to validate this. So really, I want to redo these, have it being, if it is done, then like that. Otherwise, we'll go ahead and say that. Okay, so just reversing it a little bit, because now we can assume that this is the image. And again, I'll go ahead and say the R stream, or the response byte stream, is going to be response.content. And yet again, we're going to import IO. And so we'll do io.bytes IO, the response content. And yet again, this is now seeing if this is a valid image response, right? So let's go ahead and make sure that this says this is returning a valid image, or in theory, it's returning a valid image. Okay. So now that we've got this stream here, what can we do with it? Well, I can do echo img equals to image.open of this stream. Now, when this runs an exception, that's actually something I want to see. That would be a malformed image as a response from my view. So it's a proper actual failure in my tests, right? And so now we've got that. The next one is we actually have the original image right here, which is that, right? So we can actually compare two images from Python image library with something called image chops. And so with image chops, what we can do is we can run the difference of the echo image and the original image, which was img. This order does not matter. And then we can do something called .get bbox. And what we want is this to be none, right? So difference equaling to that. And then we're just going to go ahead and assert that the difference is none, that it's literally the exact same image, right? And let's give this a shot. And there we go. Cool. So we could take it another step further and actually save the image itself and then test the save as well. But I don't think that's necessary. I think it's fine just as is. We don't need to overly test what this response would be because we're most likely not going to ever give that response back in a production environment as we've already set up. But it's still really nice to see that we can test all these things out and just ensure that, hey, we now have our functioning echo itself and we are fully able to test it. So we can have the full confidence that this endpoint, or at least parts of what this endpoint does, like these things, that it will actually allow me to then run a machine learning algorithm on this image. Now, the reason we are using Docker and Docker files is because of this line right here, line 12, Tesseract-OCR. So Tesseract is the machine learning model that will allow us to extract recipes, the actual data from a recipe, like what's in these images right here. It's going to extract that text and turn it into something we can actually use. So it's really cool that Tesseract does this, and we're going to be using that now. So we can always test this on DigitalOcean. We can go into our console and use the Tesseract app itself there, but it's a little tedious and really not that practical for the vast majority of us. So what you're going to want to do now is actually download Tesseract OCR on your local machine. So check out the documentation for it. The user manual, I think, is pretty good for the downloading. But if you're having any issues with it, please let me know in the comments. Now, if you're a Mac user, check out Homebrew. Homebrew is a really easy way to install pretty much anything. And of course, if you're on Linux, it's just apt-get install. You probably already understood that in your terminal. Obviously, not every Linux distribution uses apt-get, but for the vast majority of you, that's probably what you'll have. Now, if you are on Mac, then you just do brew, install, and Tesseract like that. And I believe it should work just fine on Windows. It's just a little bit more steps to make it happen. And then once you have it installed, you should be able to do -- version and get something like this. So that's what we're going to end up using with Tesseract. Now, the next thing is going into requirements.txt and having pytesseract. So you want to make sure that those are definitely in there, like they're absolutely working. And so what we're actually going to end up doing in a DigitalOcean in the console, we will actually use Tesseract in here just to make sure that we are all on the same page. And so what we're going to do now is we're going to jump into our app itself. I'm going to make a new file in here called ocr.py. This is really just a Python script that we're going to use just to interact with pytesseract. I'm going to show you how easy it is. So the first thing I want to do is import pathlib. Next, I'm going to go ahead and import pytesseract. And then we'll go ahead and do from pill, we're going to import image. So I don't want this dependent on FastAPI at all. I just want it completely with these three packages. That's it. So you could use this anywhere else is kind of the point. So to do this, what we want to do is set up our base directory. And that, of course, is going to be this file. So pathlib.path of this file. And then I'll go ahead and do parent. And now I want to grab the image directory. So img dir equals to, of course, that base directory and images. Now I'm just going to go ahead and grab one of the images. So I'll just say image1 equals to that image directory. And then we're going to go ahead and grab the ingredients. One PNG. Okay. So yes, we could loop through it like we did with the test, but that's not really the point of this. The point of this is to show you how easy it is to use pytesseract. First off, we need to declare the image. Let's actually call this image path instead. So we're going to declare the image with image-open, or .open rather, from that path, right? So Python image library path, that's it. Then we're going to go ahead and do pytesseract.image to string. So this actual method makes a lot of sense to me. It's, hey, what's the image? Turn it into a string, as in extract all of the things in there. And these are really just predictions, right? So we can just say preds equals that, and then I can print out what those predictions are. And that's it. So if we want to test this locally, assuming that we have it installed, I can run python app and ocr.py, hit enter, and what do you know? How cool is that? It's now giving me the actual text from that image, right? And it's pretty much identical. I don't think I see anything missing here. Now, there are ways to improve the extraction. That's not something I'm going to cover in this one at all, because this is really just about how easy it is to run a proper prediction. Now, if you are familiar with deep learning or machine learning, it's actually not a whole lot different than this. A lot of times it's model.predict and then using like maybe an image or an image array, and then it's going to be some sort of prediction as well. So using actually machine learning in the same fashion, well, we are using machine learning because of pytesseract, but using your own custom model would be very similar to this, just slightly different. But this, of course, is not the predictions that we want back. Instead, what we want back is like a list of these things. So what I'm going to do is say predictions, like an actual Python list, and that's going to be equal to, well, let's say x for x in these predictions, and we're going to split it by a new line. Because I noticed when I printed it out, it actually printed out new lines in here. So it's pretty safe to say that I can split it up by those new lines. And now I can actually go ahead and print this out and run it again. And what we see is all of this stuff. And I think what's kind of cool is we can actually think of these spaces as new lines here as well. We can consider them as that. So they're like empty list, right? Which is, I think, another nice thing. I'm actually going to leave it just like this so that when I bring this into production, I can consider it a little bit more like that. So now you're probably wondering, well, how do I implement this in production, right? Or how can I test this in production? Well, of course, we can grab this whole thing and do it all over again, right? So let's go back into our DigitalOcean app. Looks like deployment worked. So I'm going to go ahead and jump into the console. Let's just make sure that that's running correctly. So inside of the console now, this is where I could test it. So if you had issues installing pytesseract on your local machine, here's where you install it, or check it out. So we'll go ahead and do echo. So, or actually, let's see if Nano is installed. Nano is not installed. So we're going to go into CD app here. And what I want to do is I want to actually use Python in here. And this time, instead of having the file in there, I just want to see that the parent directory is correct, that it's the same directory that we're at. And there it is. Should be good. Okay. Locally, I'll leave it in as file. But again, we're just doing a quick little test in production to see this thing work. Got predictions coming through. Whoa, what do you know? It's exactly what we needed. That, I think, is pretty cool. Now, this obviously means that there's not a huge step that I need to take to actually implement this in production, implement it for real on a real view. All I need to do is import pytesseract, and then I need to essentially copy this. I'm going to actually replace my original home view, And I'll just call this my prediction view, right? And it's literally going to be that home page here. And what is it that I want to respond? This time, I do not want the file to be responded at all. Instead, I have all of these things. And hey, what do you know? I have that actual image again. So yet again, I can, delete all of these things. Just going into OCR, I can just copy, these 2 lines that I wrote out. Okay. And so this is going to be a string. So we shouldn't be too concerned about the data type in here, which means that I should be able to return results being whatever the predictions are, right? That actual list. And I could say the original, like the actual original string, we could also bring that back in as well, because perhaps I want to do something with that original string too. Like I don't want to decide that for my other service just yet. I want to get the most information I can from this microservice when it makes sense. To me, that's pretty cool. Like we didn't actually change a whole lot, and we could feel pretty good about how these things are coming through. Now, of course, we can actually test that, and we can test it on this same sort of test. Let's get rid of some of these spaces here. And I'll go ahead and copy this, bring it up. And now we're going to go ahead and test the prediction upload. Okay. So same response code should happen if it's not an image, right? And also same response here should happen if it's not an image. This time, of course, it's not echoing back an image. This time it's going to give me actual data, right? So really, I'm going to just go ahead and say data equals to response JSON, right? So whatever that data is, I want to just assert that the length of data.keys is probably 2, right? Something we've seen before. So I won't know exactly what that data is. I probably shouldn't know exactly what that data is in there. But let's go ahead and print out the data just so we can see it also being used, right? So pytest-s, and here we go. So I get an error here. We got a decode error, right? I know why. We used the wrong endpoint. Okay. Corrected endpoint. Let's run it again. This time we get a different response. We'll fix that in a second. But here we go. So here are our results and our results. That's pretty awesome, right? It's giving us exactly what we were looking for. Now what's strange is we've got a response of 422 in here as well, right? So what's happening with this? It's this one right here. So main.py. This time the echo active should be gone. So that's something we definitely don't need. So invalid image, we should be here. I don't need to make the directory either. Let's get rid of that. So I also don't know if I deleted it, but I definitely don't need it in this. Okay, so let's give it another shot. Yep, still getting an error. Okay, so let's just print out in our test here. I'm going to go ahead and print out what the response text is. See what the problem is. Nope, getting text. And I kept thinking that the error was in this right here, but I forgot this right here. This is actually doesn't have a file in it. So we're posting something without a file, and thus we're getting this 422 error. So this time I should actually put that in as a test invalid, file upload error, something like that. And let's see if the application JSON is what's coming back. The response itself should not say JSON. It should not say hello world. But if we test it out, all of those things are coming through. The response itself is not in here like this at all. So I'll go ahead and get rid of that. Okay. We can also get rid of the response text here because that's all valid. We can get rid of that data itself as well. And let's run this test again. And sure enough, everything is looking pretty solid. Okay. So yet again, another thing that I should probably test is this error with the incorrect files, like actually getting that exception now, right? So in other words, I want to make sure that this response path is not just 400, but actually uploading invalid files and just verifying that all kinds of file types are invalid, not just this one txt file. And maybe even a txt file or an actual txt file with the proper image extension and stuff like that. But again, these are like going down the rabbit hole of too much testing for this video. But there we go. We now have Python OCR on here. Now, the other thing that we still need to implement, that I still want to implement, and that is adding one level of security that this view does not have. And that is adding a token header to just really round out this microservice. The actual deep learning part of it, or the machine learning part of it for predictions, is ready to go. It's done. Now we're going to go ahead and add in some authorization headers to protect our prediction view. Now, this is not the same thing as authentication, as in we are not going to be setting up users and all this permission. Instead, we're going to just do one-off tokens that are going to be stored in our environment variables, and then we'll verify those in here. So the first thing is I actually want to create a token. So let's go ahead and do that with inside of Python. We're going to import the package called secrets. This is built into Python, and I can build a token with simply secrets and .token URL safe, and then some number, let's say like 32. I'm actually going to do this twice. So this very first one, we're going to go ahead and put it in here as simply app_auth_token, and we'll set it in just like that. Now, the thing that we want to do with the app token is we also want to put this into production. So that's what the other one is going to be. And I'm actually going to keep it local too. So app token and prod. So we now have two new environment variables, both of which I'm going to put into my main settings configuration. So app auth token. Now this one is going to be a string, right? And then app auth token prod is going to simply be a string as well, but I'll set it equal to none. So the app auth token is really the main thing that we'll definitely need in here when we use this application. And so we want to save .env, and we might have to refresh our project here and reload it like that. Now, if I were to change this to, let's say 2, and I left that setting as being required, I'll get this, validation error. So certainly if I push this into production now, that token being gone in production would bring a 500 error, an actual server error. So what that means is then I'm going to go ahead and bring my app auth token prod into production. Okay, so the production token should have no effect on the server itself, which we could try out, and it does. Okay, so I'm going to go ahead and bring this one in. Let's copy this token and go back into DigitalOcean, go into settings. You can put this on the component level environment variables or the app level. It actually does not matter. I'm going to keep it on the component level. In environment variables then, we'll paste this one in. I'll go ahead and encrypt it, and then we'll do app_auth and token. We'll go ahead and save that. Now, the reason I have a production token in my local environment will have to do with testing later. For now, we're going to go ahead and set up the app auth token for local testing. So that actual token is going to need to be inside of our prediction view here. So instead of actually making it in our prediction view, we're going to do it inside of another method, and we'll just call this verify and auth. This is not going to be a URL route at all. Instead, it's going to take in a couple arguments. The first one is the authorization argument. I'll come back to that. The next one is simply settings. And of course, it's going to be exactly what this is right here. Okay. So now what I could do is basically say if settings.debug, then I could just return, right? So if I needed to actually use the settings and trigger that in any way, I could do return. So the other thing is perhaps in my settings, I can add one more aspect of like, skip auth, right? Skip auth and being a Boolean and setting that equal to false. Okay, so skip auth in here. And we'll set that to 1. And so now this kind of comes double protected, and we can do debug and settings.skipAuth. And we can use lowercase here. So in that case, auth is verified. It's just going to return back. But now we actually need to do the header, the authorization header. So to do this, we need to import the header class from FastAPI. And we're going to set it up very similar to request or settings. It's going to be of the type header. And really, it's just going to be equal to header being none. Okay, so this is going to be the same thing on our view as well. Not surprising. And so now we have this authorization header. Now, what is an authorization header? Well, if we look at headers in general, what you'll end up seeing is something like this. Authorization, and then bearer, and then a token. Right? It's not always bearer, but that's essentially what the header is going to look like. And when we convert that to a key value pair inside of the actual request headers, it's going to be something like this, where it's authorization and then the string of bear token. And so what this argument does for this view is it unpacks that. It just gives us the value that's right here for whatever that authorization header is. So that means is that I can actually parse this right here, and that's actually what we want to do. We're going to go ahead and say label and token is equal to whatever that header is, and then dot split. Now I should actually verify if the authorization header is none, then I should actually raise a, hey, this is unauthenticated. So in other words, they're not, they never actually put in their proper authorization header. Not authenticated, but authorized. Okay, so now that we've got that, the next thing is just to test the token itself. So if the token is not equal to the actual app authentication token, right? So this right here, not the prod one, but simply settings.app authentication token. Then again, we'll go ahead and raise, this time it's actually a 401 error. Okay, and so all we need to do then in any view now is call this with the authorization and the settings as the arguments that we need. Okay, simple enough. So now going into our prediction view, actually if I run the tests now, what we'll see here is PyTest and then -s. We should get an error, right? But we don't. Our tokens are actually not coming through. So we've got skip auth. Let's actually print out what the dictionary of our settings are. Take a look at that. And so here we go. And we have skip authentication being true. Okay, that's because it's set to 1. Let's change it back to 0 and try it again. Now we get the 401 error, right? So we actually get the authorization error. Cool. So that block's working, and so is this block. Actually, this is the block that we're seeing, not the token one. So how then in our tests do we add the headers? Well, it's going to be in our test prediction upload view, right? So the actual endpoint that we just set up. I did not set this up on our test endpoint at all. And I don't think it's necessary to set it up on our test endpoint. But here is where we're going to need to put our headers. So now what we want to do is test this a couple ways. But first I'm just going to test it properly, like the actual token. And there's going to be headers equals to, well, I have to get the settings again. So we're going to import git settings. Okay, so I need my environment variables, at least my local ones. And it's going to be settings equals to get settings. And now we're going to go ahead and put in our authorization header. So authorization, and I called it bearer, but if I said jot here and used a different token, it should still work because it's going to split it up. So app auth token. Okay, so this part doesn't work, doesn't matter in our case. Now, you totally could add that as another feature that would make it matter. It's really just the token that matters. And so now if I run this again, we should be good to go. And sure enough, we are. So the other thing is I could try this same thing out as another view without the token itself. And I just want to assert that the response now is going to be simply 401, no matter what, across all the board. So now we have no token. So let's just get rid of those headers. Prediction upload missing header. Okay, and we run it again. Got no errors. I'm going to get rid of those print statements. And those might be in here. There we go. Let's get rid of that. Cool. So very basic way to get our secrets into production. And it's an incredibly useful thing because now if I ever need to change the secrets to this endpoint, all I need to do is jump in, at least the token itself is jump into these environment variables and just change what that token is. And this is meant for my one application to communicate with another application. And really, it's using open source technology anyway. So it's not like having this exposed is really leaving me vulnerable to anything other than server costs, right? Like maybe my server gets to be a lot more expensive. That's kind of the gist of it. But now that we've got that, we need to actually push this into production and then test the actual production version. All of that I'm going to just do off the video, and then we'll have it actually running into production with this latest version. So do that now. Now my application is fully in production, and if I go into my settings, I just need to verify that I have environment variables and it's related to the app auth token. So since I have those things, it's time to actually test this, the actual production application itself. So I'm going to go ahead and copy my current tests, and I'm going to make a new one, and we'll call this test production.py, and we'll paste this in here. Now, there's a lot of things that I do not want to test, including the echo statement there. I could test the homepage. Actually, this would be generally a good idea to make sure that I am fully testing the application and making sure that it's live so I can run these tests in all sorts of places. So the main way to test this is, of course, grabbing the actual endpoint itself, which is this. And I'm going to declare that right up here, and we'll go ahead and call this just simply endpoint. Okay, and so the endpoint itself is what we're going to be using. We're no longer going to be using the client itself. We no longer need that. In fact, the only thing we should probably need is Git settings, potentially these upload directories as well. But something I will need for sure is requests. So I've been mentioning that Python requests is essentially how we're doing this. And that's what we need to change all these to. So just simply requests and the endpoint, right? And so down here, requests and the endpoint, right? And I want to actually test a lot of the same sort of things in production. But the thing is, I might not always want to run these production tests, but I think it's a good idea to get in the habit of doing so. So again, requests, post, and here, production, yet again, requests, post, and here. Now, one of the key things about this test that's a little different is adding a different token, which was that prod token. That's right there. So that prod token is also what I would end up using in another application, right? That's fairly important, actually. So now let's go ahead and run PyTest. And of course, it's going to take quite a bit of time on production. Now, the reason it's going to take a while is, well, a couple fold. Number one, however many files that are in here and however big they are going to take some time to upload. Number two, the speed of Tesseract to actually do a prediction on any given server is going to vary. So depending on what your service is at, like what level it's at, it's certainly going to vary on how quickly it responds, right? So like right now I'm on a basic plan for $5 a month. If I up that up to have, more RAM or more CPUs, then, perhaps it would be a little bit faster. But that's it. I now have actual production tests, so I can add this and then do git commit, and production ready. And then we'll go ahead and push this into full-on Git production itself. In this one, we are going to deploy our FastAPI microservice for our Try Django project. Now, we're going to be doing this using the one-click deploy method on DigitalOcean, which makes things really a lot easier and a lot faster, especially for a microservice like this where we built everything out. Now, make sure that you already have a DigitalOcean account. Of course, you can find this on do.co/cfe-sh. It is also on the GitHub for this, which is the FastAPI microservice GitHub. If you scroll down to the bottom, you can click there as well. We will be deploying here in a moment, so make sure that you actually log in to your account. And so what I'm going to do now is actually just hit this button, deploy to DigitalOcean. So this is going to open up a few options that we need to set up to make this work. And the first one is creating our app auth token, right? So I certainly want to change this to something different, something more secure. And so to do this, we're going to jump into any version of Python 3. We're going to import secrets and just do secrets.token_URL safe and some number. And we could do this multiple times. Okay, so let's go ahead and grab this first one here and we will paste this in and encrypt it. Encrypting it means that we won't be able to see this password ever again. So if you do intend to use this one, make sure you make note of it, or we can reference it later, or we could always reset it later, which I'll show you as well. So let's go ahead and scroll down a little bit, hit next. And what we want to do now is just verify our name, FastAPI microservice for Django, and then you can select what region you want to use here. We'll go ahead and hit next. And then you're going to want to set up the actual size of this image, like how your CPU is set up with the various things related to that. So we're going to use 512 megabytes of RAM and one CPU. That's probably enough for this one. And I'll go ahead and launch this app. Now, it's going to take some time to actually build this for the first time. The reason for this is because it actually uses Docker as its underlying technology. Granted, we don't actually have to spend a lot of time with Docker if we want to learn how to do all of the code here. But that's what's going to happen. Every time you do a deployment, it's going to build out a Docker container with a bunch of configuration. That's actually required for this particular microservice. It's not required for App Platform, but this one in particular. Okay, so the next thing is if we wanted to change our actual environment variables, we would come into settings, find the component, in this case it's just web, and then actually run off of this. So inside of our environment variables, you'd come in here and just change that. Now, do know that if you do change it, make sure you encrypt it again. But if you save this, it actually will rebuild the service right then and there. So it'll cancel the old build, the current build, and then it'll build a new one, which will take some more time. I'm going to let this finish building and then we'll come right back. While it does finish building, what I want to show you is the code. So if you go back into the repo itself, what you will see and how you'll end up using this is by checking out this endpoint here. So we've got this endpoint. Now we can actually go from this endpoint and use Python requests to upload a file. Really, it's just this right here. So we're using that endpoint and then we open up some sort of file in the bytes mode. We are reading bytes. And then we pass in the headers for authorization. In this case, it has a JOT header. That actually doesn't matter. This label right here does not matter at this time. Maybe it'll change later. Check the README for the repo if it does. But then we actually set our token here, whatever that token might be. And that token, of course, was that environment variable that we set, right? And so if we look in here, it's this token. Now, the reason that the tests has a production version is because we need two different tokens, one for this local testing and then one for your actual deployed project. So if you end up going that direction. But that's really the main thing to interact with this. As you notice, it's incredibly simple to do. And now, of course, in my Try Django project, I'm going to be deploying this again specifically for Django. So if you end up using the Django version of this, by all means, you can watch that one as well. Now, I want to actually finish this being deployed so we can actually see what that endpoint's going to be. Now I realized there's one other thing I wanted to show you with this build, and it's based off of something very simple inside of the application code itself. So if we go back into the repo and go into .do, we see this deployment template in here. So this is actually showing DigitalOcean what to deploy from, and that's these things right here. And more specifically, the Docker file. So it knows that it's going to use the Docker file in here, which I think is actually really nice. Now, it's not necessarily going to get everything in here, but in the future it might, and this also might update and change. So be sure to check out the repo itself if something like that were to change. But the other cool thing about this, if you've watched the entire series, is you'll know that this is actually how you can make this really easy to redeploy across, well, any of your organizations or any of your applications. So in other words, if you wanted to deploy this on a new project, you can do that. Like let's say for a client or just another DigitalOcean account, you just click this and boom, there you're going to go. Or you could always update, like actually fork this code, update the DigitalOcean deploy template to whatever you need. So that's another aspect of this. Now, in the long run, when it comes to microservices like this or any sort of code that you want to use a lot of, forking it is a good idea to make sure that you at least have a copy of it in the future, or cloning it locally. That's something I definitely recommend for a service that's not going to be part of your core service especially. Okay, so at this point, the build did complete, and it's just finishing the deployment of it. And the main thing is I just want to verify that the endpoint is actually working. I click on it. This is what I expect to see at this point. Maybe in the future it's going to change, but this is a microservice API. So to actually use this, we would have to come in to using Python requests. So inside of Python requests, like the code, let's go back in here and zoom in a little bit, and then test production. We would change this to our new one, this right here. And then we could run these tests as well with using PyTest if you're not already familiar with that, and depending on when you're watching this. So thanks for watching this little demo on this one-click deployment. I realized like some of the time of it took a while just to get it up and going, but really it's pretty simple as how you need to actually set it up. So hopefully you guys make it happen, and this actually adds a lot of value to any given application you end up using. So good luck. Hey, thanks so much for watching. Hopefully you got a lot out of this one. Now, of course, if you haven't seen my Try Django 3.2 series yet, definitely check that out. That is much more comprehensive than what we do here, especially as it relates to handling and managing users, handling and managing like forms and input data. There's a lot to it. But even if you want to know more about FastAPI and how you might do all of those things, let me know in the comments. But the general idea is we now have a pretty solid foundation to actually build on top of FastAPI if we want to make it more than a microservice, or we have a solid foundation to build many other microservices, which I think is great too. So thanks again for watching, and I'll see you next time.